Need to launch a local MCP server from your client code with full control over its environment. You'll see how to use StdioTransport to spin up a subprocess server, manage its lifecycle, and pass exactly the configuration it needs, without inheriting your shell's messy environment variables. This pattern gives you precise control over how your client interacts with local MCP services.
From FastMCP client transports, import StdioTransport. Transport equals StdioTransport. Command equals Python. Args equals my server, Pi. Client equals client, transport.
This demonstrates the transport abstraction pattern for client-server communication. The code shows how FastMCP decouples connection mechanics from business logic by using configurable transport objects, allowing the same client interface to work with local subprocesses, HTTP services, or in-memory calls. The pattern works by treating transports as pluggable adapters that handle environment isolation, process management, and protocol details. Your client code interacts with a consistent API regardless of whether the server runs as a subprocess, remote service, or local object, while the transport layer manages the underlying communication channel and lifecycle. This approach solves the problem of environment fragmentation across deployment scenarios. You write client code once, then switch transports for development, testing, or production without modifying business logic. The trade-off is learning the transport configuration model, but it eliminates the need to rewrite client-server interactions for different deployment targets. Let's break it down line by line.
From FastMCP client transports, import StdioTransport.
Imports StdioTransport, the standard transport for local process communication in FastMCP. This handles stdin/stdout IPC between your client and the MCP server process, enabling direct script execution and response streaming.
Transport equals StdioTransport.
Instantiates a StdioTransport for process-based communication. This handles inter-process communication via stdin/stdout, enabling FastMCP to interact with your server as a subprocess rather than a network service.
Command equals Python.
Specifies the base command to execute the server script. This ensures the system uses the correct Python interpreter, preventing environment conflicts when launching the subprocess.
Args equals my server, Pi.
This specifies the command line arguments passed to the subprocess. Here it tells the Python interpreter to execute my server, Pi, which is the FastMCP server implementation. The pattern mirrors how you'd run the server directly in a terminal. This closing parenthesis terminates the StdioTransport instantiation, finalizing the transport configuration with the specified command and arguments. It enables the subsequent client initialization to use this transport for process-based communication with the server.
Client equals client, transport.
Instantiates the FastMCP client with the configured transport. This establishes the connection to your server process, enabling RPC calls between client and server. The transport parameter defines how messages are exchanged, in this case, via stdin/stdout to the Python subprocess. StdioTransport pattern. The StdioTransport launches your FastMCP server as a managed subprocess, handling lifecycle and communication through stdin/stdout pipes while enforcing strict environment isolation. Environment variables must be explicitly forwarded to the server, as the subprocess doesn't inherit your shell's context by default. This pattern enables powerful local integrations, but requires deliberate configuration management for production use.
The transport that hides the server becomes the server.